Good morning, everyone. Thank you for joining us today. In our last deep dive, we really dug into the Cloud Native Toolkit. You'll remember we talked all about containers, right? How they give us that amazing application portability. And then Kubernetes, acting as the grand orchestrator, managing everything at scale. We covered the basics, the theory, the architectural blueprints. But, theory can only take you so far. The real magic, the really exciting part, happens when these tools get put to work solving gnarly, real-world problems. So today we're going from the blueprint to the actual building. We're not just talking code and config files, we're talking about protecting patient data, stopping huge failures on factory floors, and delivering movies to millions of people without a glitch. We are diving deep into the so what of the cloud-native world. And this quote, this just nails what we're doing today. For all the technologists, engineers, and leaders out there, understanding the how is, let's be honest, just the price of entry. You know how to spin up a container, but understanding the why, that's what turns a good engineer into a great architect. It's what separates a company that's just getting by from a true industry leader. Why would you use a hybrid cloud for a hospital instead of just going all in on public? Why would you process a mountain of sensor data right there on the factory floor instead of sending it all to some big data lake? These aren't just little tech choices. They are massive business decisions that can make or break a company. So today, we're going to tear those decisions apart and see how putting computing power in just the right place is changing, everything. All right, so here's the game plan for today. We'll kick things off by officially making that jump from theory to practice. Then we're diving headfirst into 4 completely different arenas. First up, healthcare, where it's a constant battle between keeping data locked down tight and giving users a great experience. Next, we'll step inside the sentient factory, where the challenge is like finding a needle in a haystack of data to prevent a $1 million breakdown. After that, we'll look at global entertainment, a world where your biggest enemy is literally the speed of light. And finally, we'll ride along with the connected convoy in logistics, trying to keep track of thousands of trucks that are constantly going off the grid. Then we'll wrap it all up by pulling together the big ideas we see across all of them. Okay, let's get into it. So our mission today is simple, but it's a big one: to look at these real-world examples and see the actual, tangible business value they create. Now, you hear this term, computing continuum, thrown around a lot. What does it actually mean? Well, think of it like a spectrum of computer power. Way over on one side, you've got the huge, centralized public clouds. We're talking data centers with almost infinite power. Then, way over on the other side, you have what we call the far edge. That could be a tiny sensor in a truck, a computer on a factory floor, or even the phone in your hand. And there's a whole bunch of stuff in between, right? Private clouds, regional data centers, you name it. The real genius of modern architecture isn't about picking one spot on that spectrum. It's about intelligently orchestrating your work across the entire continuum to get the absolute best performance, the tightest security, and the best price for whatever problem you're trying to solve. And we're about to see exactly how that's done. Okay, first stop, the healthcare industry. This is a field that's just exploding with digital change right now. But here's the thing. Building an app for a hospital is not like building an app to sell shoes. The stakes are just infinitely higher. The core challenge is this fundamental tension. On one side, everyone, patients, doctors, they expect these modern, slick, on-demand digital tools. Think about it. Seamless video calls with your doctor, getting lab results on your phone instantly. But on the other side, the data itself, what we call protected health information, or PHI, is some of the most sensitive, most heavily regulated data in the world. Regulations like PPI in Canada or HIPAA in the US come with massive fines and even jail time for messing up. They have super strict rules about where data can physically live. That's called data residency. So if you're a CTO in healthcare, you've got this huge question. How in the world do you innovate like a tech startup while having the security of a federal bank? And the answer, as this slide lays out so clearly, is a really smart hybrid cloud setup. It truly gives you the best of both worlds. Let's just walk through this. Look at that first row, primary role. The private cloud is the digital fortress. It's the system of record. This is where you protect the crown jewels, no questions asked. You have total control. Now, contrast that with the public cloud. Its role is to be the engine of innovation. This is the part that scales up and down, the part that actually faces the user. Now look at the workloads. The private cloud holds all that super sensitive stuff, the actual health records, the PHI, and often it's connected to old hospital systems that you can't just move. The public cloud, it handles the dynamic, less sensitive stuff, the website, the mobile app backends, the video streaming for those telehealth calls. And finally, the key benefit. The private cloud gives you that non-negotiable compliance and data residency. The public cloud gives you the elasticity to handle thousands of people booking appointments at once and the global reach to serve patients wherever they are. It's just a perfect division of labor. But this hybrid model does more than just separate things. It actually lets you innovate safely. And this is where it gets really clever. So how can you use these incredibly powerful AI services in the public cloud without putting patient data at risk? Well, this workflow shows you the four-step dance. First, and this is rule number one, the raw, identifiable patient data never, ever leaves the secure private cloud. So let's say we have an audio recording of a doctor's visit. Second, it goes through a strict anonymization process. And we're not just talking about removing a name. This is a serious process that scrubs all 18 identifiers of what's called personally identifiable information, things like dates, locations, you name it. Third, only this clean, scrubbed, anonymized data gets sent to the public cloud AI service. For our audio file, maybe it's a service that analyzes the transcript to pull out key medical terms. And finally, step 4, only the insights, the results of the analysis, not the original data, are sent back to the secure platform. This lets you use AI to say, help a doctor quickly summarize a long conversation, all without ever breaking that sacred trust of patient privacy and while staying fully compliant with rules like PIPEDA. So, to wrap up our first case study, the big idea here is that this hybrid architecture perfectly solves that core dilemma in healthcare we talked about. You don't have to choose between security and innovation. You get to build a digital fortress that earns the absolute trust of patients and regulators, and that trust is everything. At the same time, you get to use the incredible power of the public cloud to build new features, scale on demand, and deliver an experience that feels as modern as any app on your phone. It's not a compromise. It's a purpose-built solution that plays to the strengths of each environment. All right, let's switch gears completely and see how these same ideas work in a totally different world, a modern factory. Here, the number one enemy, the biggest threat to the bottom line, is unplanned downtime. When a key machine on an assembly line, like a giant robotic welder, suddenly fails, the costs are just mind-blowing. We are talking hundreds of thousands of dollars for every single hour that line isn't moving. So the holy grail is what we call predictive maintenance, being able to see the signs of a failure and fix it before it happens. The problem? The unbelievable fire hose of data that's pouring out of hundreds of IoT sensors on the factory floor every second. And this slide right here, it just puts the scale of that data problem into perspective. We're not talking megabytes or gigabytes, we are talking about terabytes of raw data. Every single day, from just one factory. Let's get real for a second. A single motor might have sensors measuring vibration thousands of times per second, plus temperature sensors, pressure sensors. You get the idea. So trying to ship all of that raw data up to a central cloud for analysis is, frankly, a non-starter, and it fails for 3 really simple reasons. 1, bandwidth. The factory network just can't handle it. 2, cost. The cloud bills to move that much data would be astronomical. And 3, the most important one, latency. If you send data to the cloud and get an alert back 2 minutes later that a machine is about to fail, well, it's too late. The machine has already failed. You need an answer in milliseconds. The solution here is this beautiful, layered, edge-to-cloud architecture. And let's start with the cloud's job, which I love this analogy. It's the university. The cloud is the central brain, the big research institution, the historian. This is where you store massive amounts of historical data from every machine in every factory around the world. It's a data lake that has years of sensor readings and knows about every failure that's ever happened. Here, in the cloud, with its limitless computing power, data scientists can train these incredibly smart machine learning models that learn to spot the teeniest, tiniest patterns in vibration or temperature that signal a failure is coming. The cloud provides that deep historical wisdom and the big picture view of everything. So, if the cloud is the university, then the edge is the skilled technician right there on the factory floor with lightning-fast reflexes. We're talking about a small, powerful computer, an edge gateway, sitting right next to the machine it's watching. It's constantly collecting and cleaning up that high-frequency sensor data. But here's the crucial part. It's running a small, fast version of that super smart model that was trained in the cloud university. This is called edge inference. It lets our technician use the university's knowledge in real time. So it can spot the telltale signs of a bearing about to fail as it's happening and instantly flash an alert on an operator's screen or even shut the machine down safely. This is the classic, powerful train in the cloud deploy to the edge pattern, and it's a total game changer. I just think this analogy is the absolute perfect way to remember this relationship. The cloud is the university, doing the heavy-duty research with tons of data to build the intelligence. The edge is the skilled technician, taking that intelligence and using it with speed and precision right where the action is, making split-second decisions that save a ton of money. It's not one or the other. It's this perfect partnership that makes the whole idea of a sentient factory a reality. All right, let's switch gears again into a world we all live in every day, global entertainment. Let's take a big streaming service like Netflix or Disney Plus as our example. Here, the challenge is different. but it's just as fundamental. You're basically fighting the laws of physics. The speed of light is a hard limit, you know? Data can only travel so fast through fiber optic cables. So if the main server with the movie you want to watch is in Virginia and you're in Tokyo, there's a delay, a physical distance that creates latency. And that latency is what causes all the things we hate: buffering, slow start times, grainy video. The whole problem is, how do you deliver a perfect 4K video stream to millions of people all over the world at the same time and make it feel like the server is in their living room? And the answer is one of the oldest and most brilliant examples of edge computing, a content delivery network, or CDN. Let's just walk through how this works. Okay, so first, a user in London hits play on the new hit show. Their request automatically gets sent to the closest edge server, which we call a point of presence, or a POP. There are thousands of these POPs all over the globe. Now, if this is the first person in London to watch this show, the POP doesn't have it yet. That's a cache miss. So the POP reaches all the way back to the main origin server in, say, the US. And here's the magic trick. As it's pulling that show from the origin, it's streaming it to that first user, while at the same time it's saving a copy for itself locally. Now, just a few seconds later, another user in London wants to watch the same show. This time, it's a cache hit. The POP already has it. It serves it directly from that local London server with basically zero delay. The experience is just instant. So, just to be crystal clear on these two terms, because they're really the foundation of how we get pretty much all our content on the internet today, a cache miss is that first time the local edge has to go do the work and fetch the content from far away. It causes a tiny little delay for that very first person in that city. A cache hit, on the other hand, is the goal. That's when the content is already there, waiting on the local edge server, ready to be served up instantly. The entire business of a global CDN is just to maximize that cache hit ratio, to make sure that for almost everyone, the show they want to watch is already waiting nearby. And this number just shows you how incredibly well this works. A good CDN can have a cache hit ratio of over 90%. Sometimes, for really popular stuff, it's closer to 95 or 98%. Now stop and think about what that really means. It means that more than 9 times out of 10, when you press play, that huge video file is not coming from some data center thousands of miles away. It's coming from a server that is, for all intents and purposes, right down the road. That is how you deliver a flawless, buffer-free streaming experience to the entire planet. It's a masterclass in using the edge to do the heavy lifting. All right, for our last case study, we are hitting the road. We're in the world of logistics and transportation. The puzzle here is all about managing thousands of moving pieces, a huge fleet of trucks, and needing to know what's going on with them in real time. A manager at headquarters needs to know right now where every truck is, how it's being driven, if the engine is okay, and if the driver is safe. And here's the tricky part. They need this information to keep flowing even when a truck is driving through the middle of nowhere with terrible cell service. This is a classic mobile edge computing problem. So what they do is basically turn every single truck into a smart, moving edge computer. They install this tough little box called a telematics gateway inside the cab, and this box is wired into a whole bunch of sensors. You've got the obvious one, GPS, for location and speed, but it gets way cooler than that. It plugs right into the truck's CAN bus, which is like the truck's own little internal computer network. By listening to the CAN bus, the gateway can see exactly how much fuel's being used, the engine RPMs, any fault codes, everything. It's also got accelerometers to detect things like a driver slamming on the brakes or taking a corner too fast. And some of the really advanced systems even have cameras that use AI right there on the device to see if a driver is getting sleepy. So what is this little gateway in the truck actually doing? This is the key. It's not just a dumb modem sending data to the cloud. It is doing real processing right there in the cab. For instance, it provides instant feedback. If it detects a hard braking event, it can give the driver an immediate audio alert, coaching them in that exact moment. It handles being disconnected. When the truck hits a cellular dead zone, it doesn't just lose data. It saves everything up, it buffers it, and then sends it all once the connection is back. And it has its own local intelligence. It can figure out fuel efficiency for a particular trip all by itself without ever needing to talk to the cloud. This combination of the edge computer in the truck and the central cloud platform creates this incredibly powerful feedback loop. The edge, in the truck, is all about immediate action. It collects the data, gives feedback to the driver, and keeps things running smoothly even with no network. The cloud, meanwhile, is the command center for the whole operation. All the data from all the thousands of trucks flows into the cloud platform. This gives the fleet managers that God's eye view of everything on a single screen. The cloud is where they do the big data number crunching, like figuring out the best routes for the entire fleet to save fuel, or looking at historical data to see which drivers might need some extra safety training. So, we've been on quite a journey, right?
We've been through the high-stakes world of healthcare, the high-pressure factory floor, the high-speed demands of entertainment, and the high-mileage world of logistics. So what's the common thread? What's the big takeaway? Let's just take a second to step back and pull together the core ideas that we've seen again and again across all these different examples.
This right here, this is the single most important thing to take away from our whole chat today. The modern computing continuum from the biggest cloud to the smallest edge device, it's not a one-size-fits-all thing. It's not about being cloud first or edge first. It's about being workload first. The one idea that connects every single one of our case studies is this. You strategically put the right workload in the right location for the right reason. For healthcare, the right reason was ironclad security and compliance. For manufacturing, it was all about millisecond latency. For entertainment, it was beating the speed of light for a better user experience. And for logistics, it was about being resilient when you lose connectivity. The architecture always has to serve the problem. And this summary table just ties it all together perfectly. It connects the core problem with the specific pattern that solved it. In healthcare, the problem was that constant fight between security and scalability. The solution, a hybrid cloud, our fortress and innovation engine. In manufacturing, the problem was that data firehose and the insane cost of downtime. The solution, edge to cloud AI, our skilled technician and university. For entertainment, the problem was global latency and scale. The solution was that global edge CDN. And in logistics, the problem was real-time visibility. The solution was that IoT edge and cloud feedback loop. You see, every problem is unique, and every solution is perfectly tailored to match it.
The big takeaway from today is pretty clear. This whole computing continuum idea isn't some far-off futuristic concept. It is happening right now, and it's transforming every major industry. Understanding how to use these architectures isn't an option anymore. It's an absolute necessity to compete. As we've seen over and over again, where you run your code can be just as critical as the code itself. And looking ahead, our next deep dive is going to be exploring what's just over the horizon. We'll be jumping into the really mind-bending worlds of quantum computing, the decentralized future of Web3, and the critical importance of green computing. Thank you so much for joining us for this explainer. To continue exploring these topics with us, please be sure to subscribe to our channel, Tech AI and Beyond. We'll see you next time.